Welcome to this puzzle session. So here is the problem. Several football teams enter a tournament, and it is given that no two teams are allowed to clash more than once. Okay. We want to show that at any point in the tournament, there are two teams, at least two teams, which up to that moment in the tournament have played exactly the same number of games. So for example, trivially, as soon as the tournament begins, no team has been matched with any other team. So every team has played 0 games, and hence you can easily find two teams which have played exactly the same number of games, namely 0. So of course we're assuming that there are at least two teams that are participating. Okay, and suppose one game has happened, exactly one game has happened so far, then the two teams which have played, the game, have played exactly the same number of games, namely one game. So you can just experiment with it and be convinced that this is true, and of course you're encouraged to supply a full proof of this fact before looking at the solution. All right. So basically the solution is this. The problem is a purely graph-theoretic statement which has been formulated in a more colloquial fashion. The graph-theoretic statement is this: in any finite graph with at least two vertices, which I haven't written, so any finite graph with at least two vertices, there are two vertices which have the same degree. So you can refer to this top right, the link in the top right corner of the screen to go to a link to go to a video which discusses the basics of graphs. Alternately, you can check out the playlist named Kickstart. The link of that playlist is in the description below. Many videos are there, and several videos on basic graph theory are present there. Okay. I hope I do not forget to put a link. If I do, then please mention in the comments that I have forgotten a link. All right, so the statement that we want to prove is this: that in any finite graph with at least two vertices, one can find two vertices of the same degree. And to see why this is exactly what the problem asks us to do is you basically do the following. Just model every team as a vertex and fix, let's say, after, maybe 5 days, 6 days, whatever number of days that you want to analyze. So suppose after 6 days, we want to prove that there are two teams which have played exactly the same number of games. What we do is we join two vertices with an edge, meaning, edge is a notion in graph theory, so I'm assuming you're familiar with those notions. So we join two vertices with an edge if the corresponding teams, the teams corresponding to these vertices, have played a game, right? And then showing that two teams have played exactly the same number of games is as good as proving that the two vertices have the same degree. So my point is that just realize that this is the statement that we want to prove. Okay, so how do we prove this statement? So here is the proof. So suppose not. So then there is a graph. Finite graph with vertex set V and edge set E, such that no two vertices of G have the same degree. All right, so say the number of vertices in this graph is n, and we're assuming that there are at least two vertices. Okay, so we want to produce a contradiction. All right, so define this function f from the vertex set to this set, and before we define this map, note that it's a trivial observation. Note that degree of any vertex is in this range. So that's by definition of degree. Okay. So define this map F, which takes V to this set. How is this map defined? Just take V to its degree. Right? And this is a well-defined map because of this comment. Fine. Now, since we have assumed that no two vertices in the graph have the same degree, the map F is injective. That's by this assumption. But since this and that have the same size, this has size n and this also has size n, we deduce that the map F is bijective. Which is to say that it is both injective and surjective. Alright, so since it is bijective and hence surjective, there is a vertex whose degree is n-1. Okay, so suppose I have a vertex, call it whatever, x, maybe call it u. Its degree is n-1, meaning it is connected to n-1 other vertices. Which is to say that it is connected to all the other vertices, because there are a total of n vertices, and if the degree of this guy is n-1, then all the remaining vertices are joined to it. But then there is no vertex of degree 0, because this clearly does not have degree 0, and none of these have degree 0 because they have degree at least 1. And hence F is not surjective, because no vertex has degree 0, so F does not take the value 0. And that is a contradiction. So that's it. That proves this statement. And hence we are done. So a very simple proof. And with that, I want to end this. As usual, like, comment, share, subscribe. And I will see you next time.